All right, this is topic 3, day 2, relations and functions. And today's topic concentrates on the relationships between X and Y and the relationships between numbers. We still are going to see roster notation on this because that's an integral part of what we do. But we're going to go on to relationships. So Roman numeral 1 is definitions. Definitions. So the very first word we're going to define is a relation. So a relation is someone who's related to you. That's a relation. And it's kind of the same in math. A relation is any set of XY points. Any set of XY points. All right, so we're going to do some examples of some sets, and then we're going to use them to define functions or not functions. So let's say that you've got the points 1, 3, 2, 7, and 6, 5. What they'll do is put a circle around it on your worksheet, and the circle means this is a relation. It's a group. The first term is X, the second term is Y, just like you've learned. So our second relation is going to be 0, 7, 4, 3, 4, 6. And our third relation is 2, negative 3, negative 2, 4, and 8, negative 3. So each one of these is a relation. Any set of points can be a relation. It doesn't have to be 3 points. It can be 2 points or 4 points or 5 points. But in all cases, the first one is X and the second one is Y. Okay, so now that you know what a relation is, we're going to classify the relation as a function or not. So skip a little space because we're going to go back up to those. So our second term is a function. And a function is a specific type of relation, in which, and this is the key part, each X is paired with only one value of Y. So it's a specific type of relation in which each X is paired with only one value of Y. Now, when it comes to being a function, we don't actually care what the X is. The key part is it can only be paired with one value of Y. It cannot be paired with another value of Y. So let's look at these 3 relations that you've drawn and decide which ones are functions and which ones aren't. Okay, so in the first one, 1 goes with 3, 2 goes with 7, 6 goes with 5. So 1 doesn't go with anything else, so it's good. 2 doesn't go with anything else, and 6 doesn't go with anything else. So this relation is a function. Now let's look at the middle one. I have a 0 with the 7, that's fine. A 4 with the 3, that's fine. But then I have a 4 with a 6. So the 4 is paired with 2 different Y values. It's paired with a 3 and a 6, which is why this middle relation is not a function. All right, let's look at the last one. We have 2 paired with negative 3. Okay, negative 2 is paired with 4. 8 is paired with negative 3. Now, this one sometimes confuses people because they're like, well, there's 2 negative 3s. Remember that we don't actually care which Y it's paired with as long as it's only paired with one Y. So 2 only goes with negative 3, so that's still good. 8 only goes with negative 3, that's still good. So it doesn't matter that they both go with the negative 3. It's that the X has only one y. So this is actually a function. So it's kind of a one-directional relationship that we're working with. Okay, so another form of question you're going to see is the domain range type of question. So we're going to label this up top in a second. So leave a line, and they'll have domain and they'll have range. And underneath of domain, let's say they've got 4, 3, and 5. Under range, we've got 2, 6, and -1. Now, we've talked about domain and range before, but to review, the domain is the set of all x's, and the range is the set of all y's. Even if they don't write domain and range, you always assume it's left to right, that domain is first and range is second. So in this style of a question, they're going to show you how the x's and the y's are related using arrows instead of putting parentheses around them. It's just a different way to write it. So let's say 4 goes with 2, 3 goes with 6, 5 goes with -1. So in this arrangement, 4 only goes with a 2, but nothing else. 3 goes with a 6, but nothing else. 5 goes with a -1 and nothing else. So in that arrangement, this is a function. All right, so we're going to use the same one. Let's say that you've got the number 0, and the arrow goes from the 5 to the -1 and the 0. So now my 5 is being paired with more than one y. It's being paired with a -1 and a 0. In that case, this would not be a function. All right, so here's another style of problem you're going to see. They're going to use, this is actually roster notation. Let's say set A equals, roster notation can be used with XY pairs. So can set builder. So in this one, we have the pair 3, 2, comma, 5, 2, comma, 7, 1, comma, and the last one is 3, -1. End with a brace. All right, they're going to ask you, what is the domain? You can use roster for that. So remember, your domain is the set of all x values. So when you list the domain, you're going to list all the x's. Don't list duplicates. So I have a 3. Here, remember, the first one's always x, and the second one's always y. So I have an x that's a 3. I have an x that's a 5. I have an x that's a 7, and then I have another 3, but I already listed that, so I don't list the 3 twice. So that's my domain. It's all the x values in the set. All right, now we're going to do the range, the set of all y values in the set. So I have a 2. I have another 2, but I'm not going to list that twice. I have a 1, and I have a -1, and that's my range. End with a brace. The last question they're going to ask you is it a function or not? So looking at this, I have a 3 paired with a 2. But then later on, I have a 3 that's paired with a -1. So my x is being paired with 2 different y values. So this is not a function. Okay, so that's your basic relation and function questions. Now we're going to go on to function notation. So this is Roman numeral 2 function notation. Okay, so if you understand the purpose of function notation, or at least its origins, it's a lot easier to remember it and keep it straight. So basically, function notation in its most basic form solves a particular dilemma. Let's say you've got y equals 2x plus 3, and you have y equals 3x minus 1. In its most basic form, function notation is there to help you distinguish which equation you're talking about. If I say, okay, take the equation, solve for x, you're gonna be like, which one? They're both equations, they both have y's in it. So what they do in function notation is they give the equation a name so you know which one you're talking about. So for this, what you do is you take the y and you replace it, and we're gonna replace this one with f and then an x in parentheses. And this one, we're going to replace the y with g and then x in parentheses. And then let's talk about what that means. Okay, so the letters F and G, those are the name of the equation. So I have equation F and I have equation G. So that's the first thing that function notation tells you is which one is which. Okay, the second part of the notation is the x in the parentheses. The x in the parentheses says that the equation has only x's and numbers. There are no other letters. So the letter in the parentheses tell you what the variable is in the equation. In this case, it's in terms of x. So you're only going to find x's and numbers. You're not going to find z's or m's or n's. You're just going to find x's. Now, if I were to write out exactly how to read this g with the x in parentheses, it would be the function called g in terms of x. The function called g in terms of x. Now, we're math people. We really hate long, wordy sentences. So you can say the function called g in terms of x, or you can use the short name, which is g of x. And basically the g is what it's called, and it's in terms of x, g of x. So this would be f of x. This would be g of x. And you'll hear me say that quite a bit. So that's how you read function notation. That's what it says and what it tells you. Okay, so number 2, we're going to calculate in function notation. The actual math is pretty simple. The main point is you're learning to recognize function notation and how to use it. That's the focus. Okay, let's say that you've got f of x equals 2x plus 3, and you're supposed to find f of 2. Okay, so f of 2 says you're going to use equation f. So it tells you which equation, because in some of these you're going to have more than one equation listed. So the f tells you which equation. And the 2 says that you're going to replace all x's with 2's and simplify. And again, the f just tells you which equation you're going to use. That's its sole function. So replace all the x's with 2's and simplify. All right, so let's do that. Here we go. F of 2, because I'm replacing with the 2, equals, I'm going to replace the x with the 2. So instead of 2 times x, I'm going to use parentheses, 2 times 2 plus 3. You multiply before you add. 2 times 2 is 4. 4 plus 3 equals 7. So your answer would be f of 2 equals 7. I replaced the x with a 2 in equation F, and I got a 7. This is function form. It's actually just a point. The x is the 2, the y is the 7. So in coordinate form, it would be 2 comma 7. That would be coordinate form, which is what we've worked with most of the time. That's your x, that's your y. So function notation and coordinate notation show the same things, just using a different notation. All right, let's do another one. Example 2. Find f of negative 1. So I want you to actually do this one. Find f of negative 1. All right, let's see how you did. So we're going to use equation F. We're going to replace the x with a negative 1 and simplify. So here's equation F. So instead of 2 times x, it's going to be 2 times negative 1 plus a 3. We multiply before we add. 2 times negative 1 is negative 2 plus 3 is a 1. So f of negative 1 equals 1. And just like in a coordinate pair, x has to go with y. The negative 1 and the 1 have to be part of the same answer. All right, last one. For some odd reason, they do this input-output chart. So it always throws people. So it's kind of like drawing a rectangle with a little funnel at the top and a little funnel out the right side. And the way it works is the input comes from the top. So x is your input. It is substituted or inputted into f of x equals x minus 2. And the result is the output, which would be x minus 2. Yeah, I'm not really a giant fan of these, but the key part is that is basically your equation. So they're going to ask you something like, find f of 3. You do not have to recreate the whole input-output chart on your paper. Please don't. F of 3 and use that equation and do what we just did. It's just off of a input-output machine. So f of 3 equals, substituted in for x. So 3 minus 2, which is 1. So f of 3 is a 1. And that would be your answer. So that's an input-output chart. Not real fancy. Okay, that is the end of the notes today. Are there any questions? Yes.
So when you're giving your final answer, with functions, do you have to put it in coordinate form or do you just leave